This is a video of an example of a polar function and taking derivatives of it. So the first question is to find dr d theta and evaluate it at pi over 6. So if r is equal to 4 cosine theta, then dr d theta is equal to -4 sine theta. If you were worried about whether you needed a d something over here, it would be d theta, which would just be 1. So the derivative we're looking for is just -4 sine theta. And if we evaluate that at pi over 6, then we get -4 times the sine of pi over 6, which is 1/2, and we get -2. So if you needed to interpret that value, you would say since dr d theta is less than 0, the point on the graph is getting closer to the origin. This distance r is decreasing, and if r is decreasing, then the point on the graph is getting closer to the origin. So if you wanted to write in the interpretation here, it would be since dr d theta is less than 0, the point on the graph is getting closer to the origin, or the polar function is getting closer to the origin at when theta equals pi over 6. Question B is to find the parametric form of the polar function and evaluate it at pi over 6. So the x will be r cosine theta, and you just take the r that was defined, 4 cosine theta, and substitute it into the r value. So I'm going to take this and put it here. So that will become 4 cosine theta times the cosine theta that was part of the formula. And so this gets simplified to 4 cosine squared theta. And so that's the x-coordinate of the point. And then the y-coordinate I will get by using the formula r sine theta. And I'm going to put in the 4 cosine theta in for the r, and keep the sine theta. That's part of the formula. And so that is 4 sine theta cosine theta. And it's a good idea with this particular situation to consider changing it to a little bit simpler form using the double angle identity, which would be that sine 2 theta is equal to 2 sine theta cosine theta. It's a double angle identity from pre-calculus, and that would change this function to 8 sine 2 theta. No, it wouldn't be 8 sine 2 theta. It would be 2 times 2 sine theta cosine theta, and 2 sine theta cosine theta would be, this part would change to sine 2 theta. So it's 2 sine 2 theta. And that will be helpful a little bit later on. Sorry about that confusion there. Then the question also asks us to evaluate this at pi over 6, which I think is important so you can wrap your head around what it is that we just found here. So if I substitute in pi over 6 into the x-coordinate, I would get 4 times the cosine of pi over 6, which is √3/2, and then square that. So that would be 4 times 3/4 or 3. And that's saying that the x-coordinate on this function when the theta value is pi over 6 is positive 3, which looks pretty good there. And the y-coordinate at pi over 6, we could use any of these formulas here. I guess we'll go ahead and use this one. 2 sine of 2 times pi over 6 will be 2 times the sine of pi over 3, which will be 2 times root 3 over 2 or root 3. So the y-coordinate here is about root 3, or is exactly root 3, which is about 1.7. This is 1, 1.5, 1.7, so that looks pretty reasonable. All right, so for part C, it asks us to find dx d theta, and that would be just taking this 4 cosine squared theta and taking its derivative with respect to theta. So it will just be a chain rule situation. So 4 just gets rewritten. The 2 will come down in front to the first power, and then multiply that by the derivative of cosine theta, which would be negative sine theta. And so that becomes negative 8 sine theta cosine theta. And you could also change that negative 8 sine theta cosine theta into, you could use this identity again. So that would be negative 4 times 2 sine theta cosine theta, which would be negative 4 sine 2 theta. And then it says to evaluate dx d theta at pi over 6. So dx d theta at theta equals pi over 6 is negative 4 sine of 2 times pi over 6 would be pi over 3. So it'll be negative 4 times root 3 over 2, which will be negative 2 root 3. And if we were going to interpret what that means graphically, you would just be expected to know that since dx d theta is negative, the x-coordinate on this graph is getting smaller. So since dx d theta is less than 0, the x-coordinate is decreasing. The x-coordinate on the function is decreasing. And before we get to question D, it's going to ask us to, since it's asking us to find dy dx, we also are going to need to know dy d theta. So just in preparation for that question, I'm going to go ahead and find dy d theta right now. And this is where it comes in handy to have written the y function in terms as simplified as possible. So if you left it in this form, 4 sine theta cosine theta, then you would need to use the product rule. And if you use this trig identity, when you go to find dy d theta, now you just need the chain rule. So I think it's a little easier with the chain rule, but you could definitely use the product rule if you prefer. So the derivative of 2 sine 2 theta will be 2 times cosine 2 theta times 2, or 4 cosine 2 theta. So now if we do part D, dy dx is equal to dy d theta, 4 cosine 2 theta, over dx d theta, which is negative 4 sine 2 theta. And then if we simplify that, we could get cosine 2 theta over sine 2 theta. going to cross out the 4's here, and let's go ahead and do, since I'm running low on space, dy dx at theta equals pi over 6. Cosine 2 theta at pi over 6 would be the cosine of pi over 3. And this would be the sine of pi over 3 with a negative out there. And so this equals, the cosine of pi over 3 is 1/2, and the sine of pi over 3 is √3/2. And if we do that division, we end up with 1/2 times 2/-√3, or 1/-√3, or -√3/3 would be the slope of the line tangent to the graph right here. I do have this all set up on Desmos, so I thought that I would show you. As far as interpreting this graphically, it just means that the slope of the line tangent to this point at when theta is pi over 6 is -√3/3. So that line is this one, and that's our slope of -1/√3 or √3/3. It's going through the point with an x-coordinate of 3 and a y-coordinate of √3 that we found earlier. And if I play a point going around here, then it's showing that the r is getting smaller right now. The x-coordinate is decreasing, and just shows all the features of this graph are if theta equals 4 cosine theta. One thing that's interesting to note about the graph is that the whole cycle finishes in pi. And when you are at a value of, say, anything a little bit bigger than pi, the coordinates here are, the radius values are negative. Anything bigger than pi over 2. So here is pi over 2, 1.57, gives you a y-coordinate of 0, or a r value of 0. And then as soon as you're past pi over 2, then the r values are negative, and you complete the circle at pi. 3.14. Somewhere about right there. And then as you go around to 2 pi, you're just completing the circle twice. So the whole graph finishes in terms of, in one cycle, one complete circle finishes as theta equals pi, and you overlap the graph if it's 2 pi. All right, so you can try the homework assignment that goes with this lesson, and thanks for watching.